Good morning, guys. Can you hear me and see my screen? I got Corbin and Rory with me here. I'm not sure where everybody else is unless they're forgetting how to find the Zoom link. We'll have to give them a few more minutes. Good morning to you guys that are just showing up. I'm trying to get us a few more people in here. There's a few more, and there's 4 of us now, 5 including me, but I like to get us closer to 10. But I'll get started here in a couple more minutes, whether they're here or not. I'm going to go ahead and get started. Looks like snow or something's causing us to have low enrollment today. We want to try to keep coming to these meetings where you can converse with me as much as you can. Today's later class, if you're in that class, is going to be pretty difficult. So, you know, if you miss this stuff, I know you can watch the video, but, you know, just want to put it out there since we're about ready to get started. So, okay, sounds like some people are having problems with the connection. That's what I'm hearing. Okay, well, that's kind of what the problem is sometimes we have with the blended courses and whatnot. But let's go ahead and talk about what we're doing today. And there's 7 of us. I got 7 down, so we're going to get rolling. First, if we click on home, you'll notice that we do not have a week 2. And that's just because this is still week 1. If we want to make it a week 2, I could have, but it's just going to cause confusion. So Wednesday and Monday were week 1. This coming Wednesday will be the first day that we are on campus, and it's going to be fun. You guys are going to be working in your harnesses and practicing climbing, working with some of your gear. That's always a really good time. And we've got a lot of activities that we're going to be working on in regards to going up and down the tower, doing some ropes and rigging. So there's going to be plenty going on. And we don't want to miss it because it's stuff that's hard to make up. So make sure if you can't make it today, make sure you're making it on Wednesday because that's essential. All right. Now, when we click on module 1, what we'll notice is that in module 1, we last week just went through a very simple technical document, just to get us started in the class and give you guys something to do. And I want to make sure that you understand that that was one thing that we need to do. So that's assignment 1, and that's what you want to submit as soon as you get that filled out. And today we're going to be going into fall protection training, fall protection. We have a worksheet that we're going to go through, and we'll also talk about a couple knots that we need to practice tying and getting ourselves ready to do, because when we come into class on Wednesday and then the following Wednesday, we'll be in the Flex Lab. So we'll first meet at the Craig Porter Energy Center like we're supposed to. That's where our classroom is held. We have harnesses there. We'll kind of go through some stuff as a group. Hopefully I'll have more faces and then make sure everybody's all up to par and up to speed on what they need to do. This next section, when you scroll down through what's in module 1, you'll see that you have this fall protection training worksheet, which goes along with this fall protection wind energy Copman rescue training book. It's a pretty big book, and that's one thing that we're going to be going through today. And the homework is really, it follows along the reading. So it's more like a note-taking type homework. So if you were working on your different projects and you're trying to take notes, this is going to be a good study aid for you, is what it is. And so it's a little different. It's a lot like the last one. So you just have submission. It's not always going to be that way. So we'll have some stuff that's in Canvas that'll be multiple choice coming up soon. I did want to also talk about, there is a book that goes with this course. You don't have to purchase this book, because most of this stuff I'm going to be lecturing and talking about, but it's highly recommended that you purchase the book. So let's take a look at what that book is. If you want to just go to Amazon, you could type in Maintenance Fundamentals for Wind Technicians. So this is the book. So you can rent it or get the e-textbook. I would just get the e-textbook. It's $35, or well, I guess it's 70 to buy. Let's see, it's so expensive. But there's a paperback version of it for 35 bucks here if you want to go with that. But I'm going to be referencing this book in these videos as we go along. If you're struggling with some of the information that's in this text, this is the textbook that you need to get. Although, again, it's not 100% required, but it is going to be a little bit easier if you have your own book. Okay, so definitely recommend getting the textbook. Is there any questions about anything so far or the textbook? Okay, so normally I would put that as a requirement in the syllabus. And let's go ahead and get out of here. Now, we're not going to be using this textbook for a couple weeks anyway. So you got time to get one and we can talk about it again. We're still working in these first packets. That's part of why I do these packets at first, because most of you guys don't have a book yet to go with this information, or you can't. You got to talk to me about it. Just let me know if you want a book and you're struggling with it. Let's see here. I did also want to go back to our page. There is the YouTube Energy Link page. It's up and running now, so you should now be able to see the week 1, last week's lessons there. So if you need translations or anything like that, that's why we do it. If you are okay with just using the Zoom recordings, you can use those too. So I will post those videos in there as we go through our information. Okay, make sure I'm in the right spot. Okay, so let's see, we've got somebody else in here now. Got it. I got a Tara here, but I'm not sure who that is as a student. You'll just have to pop in and let me know that you're here if you can. Anybody on a telephone called Tara? Yeah, you may not know. Look in the participants and you'll see.
Professor Rudowitz, can you hear me?
That's you, Landon, isn't
Landon, yeah, sorry about that. I was having some internet problems this morning.
Everybody's having that this morning for some reason. Maybe it's the snow. I don't know.
Yeah.
But okay. But we're all good and recorded. You should be able to watch everything that I just said. So
okay, great.
Yeah, and I wanted to mention also, I want to go over here to modules, that we have a YouTube page that has the old video links. So
okay,
that is a little easier sometimes than to use Zoom to rewatch the videos.
Oh yeah, yeah.
Because the Zoom's kind of complicated, so you just pop YouTube on anytime.
Oh, okay,
so
great. Yeah.
That takes me a couple days. I'll try to get it done as soon as I can. But the Zoom video recordings will be available right away. So
okay, I know this last time it seemed like the audio for Zoom wasn't working that well. At first, you had to let the video play for a little bit and finally
keep right. Yeah, I found a new way to test my stuff, so I was able to get up and going today pretty good. As long as you guys can hear me, I'll go ahead and get us going.
Right.
Okay. So when we get into this section here, I want to go ahead and click here. What you're going to want to do is click on down to our Wind Rescuer training course book. You also have this fall protection training worksheet. I would, if you're with a computer right now, you know, you could get started on that right away. So we're going to click through. This is last week's work. And that should be last week's worksheet that you were to download, and then to type in your answers that goes with the technical specifications of a GE 1.5. And that we wanted to try to get done by Wednesday. So if you're still working on it, that's fine. You know, try to get that done by Wednesday. We often do these. There's the submission there. So as soon as you're done, you would submit it. You click on student view and you can see, you would hit start assignment, hit submit. Okay, so you should, those are all Word documents, should be able to just download as a Word document and then just type and fill it in. You shouldn't have to print it out. This right here is the DBI Sala Fall Protection Training Wind Energy Competent Rescuer book that we are using. I had mentioned that this is a pretty expensive training course to go through. So we're kind of doing it loosely, not officially, but you're going to get the information so we can go through this. And what comes up next is you have the worksheet for that. And this worksheet looks large. I changed the due date on it. I think I had it due on Wednesday. I don't want that since we didn't get to it last week. It won't be due for a week either. So you should download this and fill this stuff in. Now, going through this fall protection book is important. Your textbook covers it a little bit. When we get into our next lesson, module 2, we'll be going through a couple safety lessons right away at the beginning. And they do go along with this, but they're not as detailed. So that creates a little bit of an issue. So that's why we go through this in great detail and just talk about fall protection as if you were in a fall protection training class. And then on Wednesday, you'll be able to get in there and you'll have a much better idea of how to wear a harness and all the rules that go with your harnesses, and you'll be able to climb and start performing on our mini tower. And we'll just see how you do there. There's just some basics that we want to practice, but within this worksheet, we're going to start on introductions in our little book, and then we have the questions that you just answer. So you should be able to download this, fill in the blank. There might be a couple typos on it. You can if you got an A, B, C question, you can just highlight the answer that you want in bold type. But I'm going to go through most of these questions with you guys today. That's what I'm doing. So you're going to be able to just do kind of like a little study guide with this. So there's quite a few of them. And so this is going to take a little bit of work, but this is important. This is about safety. This is about your fall protection. If you're going to go into wind, fall protection is very important. And there's several things that we need to learn about. And then we'll move on from that. So you'll see that you got about, it says 57 questions on the section 1 through 3. And then we add this section here 4, and there's just a few more sections to wrap up this book, because this book is huge. The book is, I think, 88 pages, and I tried to concise this down as much as I can to where you guys can go through it. So let me do that. And what we're going to do is just go ahead and get into this book. Is there any questions for me before I get started? I got Cameron here now. Okay. And if you are late, again, you should be able to watch the video. And always scrub through the videos. The beginnings are usually short and quiet, waiting on attendance, things like that. Once you get it going, you should be able to hear the audio. Okay. Let's see.
Hey, Don.
Yes.
When do you actually plan on getting us in class so we can, or in the lab?
Wednesday.
Wednesday. Okay.
Yeah. Every Wednesday from now on.
Okay.
So Monday's just going to be, we're going to spend an hour to 2 hours talking about the material, answering any questions that you guys have. I like to go through it with you just to help you. So you feel like you've gone through it once, and then you go through it again when you do your homework if you haven't got finished already.
Yeah, definitely. Absolutely. That's good. It's actually had me thinking about wind turbines all the time, even when I'm just laying around. So it's processing everything.
Oh, that's exciting. Yeah. Very good. Because we're gonna get into stuff that's fun. I don't like some of this stuff any more than you guys. We want to get our hands dirty. We want to play with some stuff and learn. And but we got to also get information in your head and get that information structured so you guys can pass your tests, or you won't know what to study. So we've got this first packet here. All right, let me get that open. Actually, let's just do this. Scroll back. And I'm going to open this up all the way. Okay, so fall protection training, wind energy competent rescuer. That's what we're doing here. So everyone should be able to see the book. It's not in color, so if you want to print it and keep it, it's pretty easy to print. What we'll start about just introductions and the standards, some of the things that we need to know. Then we'll go into some fall protection basics. What we have to do is define the difference between fall prevention and fall arrest. Then we'll learn when it's okay or not okay to wear body belts and different types of full body harnesses. There are connectors that we need to look at: snap hooks, carabiners, lanyards, and energy shock absorbers. These little quizzes are part of your worksheet that you're doing, that you'll submit, the one that we just looked at. So those quiz questions are part of that. And we'll go over those today. Then we're going to finally go through anchorages here, and that's where your assignment ends right here. There's a couple questions on section 5, really short, but you're really only needing to do your homework through about page 40, something like that. And the rest of the stuff we're going to pick up from our textbook and when we get into class. So I will go through this quickly towards the end. That'll speed this process up a little bit better. And really, you're going to learn what you really need to know once you have a harness on and once you're climbing. But what we need to do is learn terminology. And so in one way, you could look at what we're doing right now is if we're standing in the lab, but I'm not going to let anybody climb the tower till we talk about your harnesses and your equipment. So that's what we're planning to do, is talk about our harnesses and our equipment. So a fall protection program is a program that is designed for people who have fall hazards as part of their job. We want to make sure that they know how to use their equipment properly, not only for your safety, on yourself, but for the safety of others. And we need to learn how to inspect our equipment, hook it up properly, and make sure nothing bad happens, because it does happen and people get hurt. So the standards that we're talking about is Z359, or the ANSI standard. So when we talk about one of the questions, it says, what is the ANSI fall protection standard? Well, ANSI is just the American National Standards Institute, or there's also CSA, the Canadian Standards Association. So they put their stamp on these equipment. That means that they've undergone a series of tests. And so a lot of those tests and requirements mean that those harnesses have to meet certain weight requirements. They have to be able to hold 5,000 pounds. The different carabiners all have different weight limitations, and some of the stuff that you can go out there and buy is cheaper than other stuff, right? And that would mean there's a good chance if you and your employer should provide all your equipment anyway. I wouldn't worry about it too much, but you want to make sure that you've got quality equipment is really what I'm trying to say here. So this is all just talking about ANSI and the CSA, and Z359 is the section. We're not going to read that because that is like reading a really, really dry, boring manual. It's like NEC code. So why do we have to have this harness and everything? Well, it has to do with the fact that OSHA. So there is OSHA regulations and standards that go with this. And we're looking at OSHA 1926 subpart M for construction. And then that's right there. And then 1910 for general industry. And what that means is these regulations require fall protection when working 6 feet above the next lowest level. Furthermore, within the industrial establishment, guarding is required on platforms that are 4 feet or more. So we're just talking about versus the construction industry or versus the general industry. Your next question is going to be asking you, what is it required? So fall protection is required when working at or above 6 feet in construction or 4 feet in general industry. So you're generally going to have a harness on when you're working on a platform higher than 4 feet. That's what they're telling us. So there's a hierarchy of fall protection that we need to look at. And the first step is elimination or substitution, removal of the fall hazard. That means if we're looking at a situation where we possibly can fall, then we need to either engineer the hazard out or remove it through fall prevention or fall arrest. There's passive fall protection, which is something more like a guardrail. And there's fall restraint. That's going to be more closer to, it's an anchorage preventing the worker from reaching the fall hazard. And then there's fall arrest. And that's your harness basically. So there's a few confusing elements that I like to discuss. So if we were to look at our worksheet, we would be around question number 4 on our worksheet. And question number 4 asks, fall protection refers to what? Well, we would find that information once we get down to the next couple of questions. So there's the preferred hierarchy of fall protection. Okay. So when we're looking at fall protection, question number 4 really comes right from this right here. Fall protection refers to the overall industry and process of protecting workers at height. Okay, simple enough. Now, why am I making you learn some of these definitions? The reason why we're learning some of these different definitions is mostly because they sound the same, but they're not. So you'll get a little confused. So the next question is talking about fall prevention. What do we mean by fall prevention? Well, fall prevention refers to those systems and those techniques that eliminate the possibility of a fall. Right there. So those are just some definitions that come into play here. We have to assume when we're talking about fall arrest, you know, they're talking about just the facts. So some of these are just like the keys to what this whole fall protection training program is about. So understanding fall protection, fall prevention, the differences between that and fall arrest. We'll learn a little bit about warning lines and controlled access, but we're mostly going to be focusing on wind tech type work, which is really just going up and down a ladder with your harness and then tying off with lanyards if you're outside the turbine in any form or shape. But most of the time, it's not that difficult to understand really what we're trying to learn, because we're not getting too crazy into every type of fall protection there is. Okay, so number 6 roughly is where we're at. Number 6 says fall arrest systems should always consider, and that should be B, free fall or legislated to a maximum of 6 feet, deceleration distance, swing fall, and safety factor. So they've got some of this stuff right here at the very beginning. Okay. Number 7 on your worksheet says a worker using a full body harness connected to an anchor point with a lanyard is specifically using, and that's what we're going to call fall arrest. So let me repeat myself. A worker using a full body harness connected to an anchor point with a lanyard is specifically using a personal fall arrest system, or that is fall arrest. That is not fall prevention. That's why it gets confusing. Included within fall protection arsenal are systems that fall under the fall prevention. So when we talk about fall prevention, we're talking about guardrails, stair rails, ladder cages, fall restraint systems, warning lines, control access zones, those types of systems. So think guardrails, that's where your mind goes, or any type of restraint, something to keep you from falling over an edge or falling out of a door or falling through a hatch. You know, there's something there, like a door that's locked or a ladder cage, something there. That's fall prevention. Fall arrest is your full body harness connected to an anchor point with a lanyard. Is there any questions on understanding the differences between fall arrest and fall prevention? Okay. So we're on question number 8. Question number 8 says fall protection systems should include. What you want to list is these 4 things here in your own words. And just simply, when we're looking at a fall protection plan, we identification of the fall hazards in each area. And that's something we can't ignore, because you can come into a new situation where you've never worked in it before, just like any of you that are first starting out. You need to be very aware, looking for the fall hazards or any type of fall hazard or hatches or things that could cause a fall that you want to know about. Your supervisors and your other colleagues should help you stay aware of that, and you should help them. You also want to detailing the fall protection system or equipment used in the area. So know your equipment. That's part of a fall protection plan. And then implement, assemble, maintain, inspect, which is a very big part of fall protection. If we don't look at our harness regularly and inspect it, it could be damaged. And organizing a rescue plan. So we won't be able to get into good detail on the rescue plans, but we have rescue equipment at the campus. When we go to the climbing lab, the manufacturing lab, and room GH 173 in Griffin Hall, which is where we'll be next Wednesday. We'll be using some of that equipment when we get to that point. Okay. So when we start here, we're looking at fall prevention. And we're on question number 9. Question number 9 is simply just asking what you're supposed to do when you first deal with fall prevention. And the first step to safeguarding workers at height is to try to eliminate the fall hazard. Eliminating the fall hazard is something that can be done either through a modification, this may be accomplished, modification of work procedures. So how you think you're doing it may not be the best way, or it needs to be engineered out with the modification to the area. So that means the engineers or the designers of the systems need to put in a place for you to tie off if there isn't a place to tie off. And once we get going and we start seeing areas, so in my case, when I worked and I was building GE wind turbines, they used to have a platform at the very first deck. And so you would climb about 10 feet and go to a deck where you had some boxes with electrical wires that you had to work on. And after they changed the model number, the turbine was pretty much the same turbine, but they just took the deck out and there was no way to reach those boxes anymore. They had failed to engineer out the hazard. They created a hazard when they did that. And they were just trying to save money on steel. And so we had to build scaffolding to get up to those boxes now inside a wind turbine, which seems kind of ridiculous when you start to think about it, just to be able to reach some of the equipment. So number 10 is, this is also sometimes referred to as engineering out the hazard. So we've already answered that question. Moving on to question number 11. It's pretty simple. again, we're just talking about fall prevention. So we're talking about guardrails and handrails. Those are easy to understand what they are. And question number 11 is just the minimum numbers that they have listed right here on a guardrail. If it's going to be installed, guardrails are referred to as fall prevention. They can be 42 inches with a mid rail at 21 inches and a top rail pull test of 200 pounds. I'm going to throw some numbers at you. The guardrail one is about the only one when we're talking about fall prevention, when we're really looking at numbers. When we get into our harnesses, I'm going to throw some other numbers at you. You do need to know those numbers. If I were to walk up to you and ask you how much your harness can hold, what's the weight, you know, just saying, oh, it can hold my weight isn't enough. You need to know that it's designed to hold 5,000 pounds. And so number 11 should just be pretty easy. We just fill out that information. We're recognizing that guardrails are fall prevention. Any questions, comments? You're moving on to question number 12 now. Warning lines. So warning lines are used to cordon off hazard areas and are identified with colored flags. This is really important to me because my father had an accident many years ago when he was walking on a roof, working at General Foods in the factory, and somebody had pulled the tarp over a hole, and they did not cordon off the area with colored flags, red tape, anything, and he stepped in the hole and fell 20 feet and broke his back and his arms and his legs, and it hurt him his whole life. So you got to be aware that other people can get you hurt, and you want to make sure that you're looking at what's around you. That's why I say when you work at a height, you want to think about what are the hazards. Is there any hazards on this? I mean, if you weren't doing wind, you might be working in solar, or you might work in both. But you might be on a roof in a harness instead of in a wind turbine at some point. And the point of this would be there could be dangerous areas on the roof. Make sure you take a moment to look around. Okay, looks like we got someone else that finally made it. Tyron, I see you. Okay. Number 12. We already answered that. The next section that we're going to get into is warning lines. Let's see, we just did warning lines, ladder cages. There we go. So ladder cages are also part of fall prevention. And there's really not a whole lot that we need to worry about too much with ladder cages. There's just, he mentions ladder cages aren't used in wind turbines really because the danger of falling. We have a ladder that's really close to the wall of a wind turbine, and when we get looking at some pictures and some climbing techniques, we'll see if you have a ladder cage, the tendency is if you were to fall that you might bounce around inside this cage a little bit too much. So they're only going to be so big anyway. But what we just need to know on number 13 is ladder cages are merely intended to restrict your movement. And it's been noted they are also, they account for some horrific injuries, as we mentioned, and very difficult rescues. So depending on if a person is all been out of shape when they fell through the ladder cage. So ladder cages aren't used in wind, but they're briefly mentioned here, and they would be part of fall prevention. Fall restraint systems are designed and rigged to eliminate the possibility workers fall to lower levels. So we're starting to get into controlled access zone areas. So a controlled access zone area would be an area where it restricts the workers, where they're at risk for falling. Okay, let's see here. The next section covers controlled access zones. And that is the area that we're talking about in regards to fall prevention still. So we can see question number 14. Controlled access zones are areas of restricted access where workers are at risk of fall. Question number 15 says controlled access zones are only implemented after so that goes down to the discussion that they do a feasibility study. In other words, a feasibility study is conducted and then determine that all other fall protection systems are considered impractical or would cause additional hazards. So then they would move to a controlled access zone. We don't really have controlled access zones in wind, not to my knowledge. So it's not real important for us to get too deep into controlled access zones at this point in time. The next section is fall arrest. Give me a moment. I need to step away from my computer for just about 2 minutes and I'll be right back. And then we'll start on fall arrest. Okay, I am back. I just had to take a moment for myself. Fall arrest. So question number 16 asks a real simple question. Engineering can always eliminate the hazard. And the answer to that question is false. It can't always eliminate the hazard because the hazard is something that may require you to work at the very edge or on the backside of a ladder or in a way that you really have to have other fall arrest prevention equipment like an SRL, self-retractable, put into place, so engineering can't always eliminate all the hazards, and you've got to be smart about it in your mind. So while fall prevention protects the workers by eliminating the hazard, it is recognized that engineering cannot always eliminate the risk of fall. So that's what we're talking about when we're starting to move on from fall prevention, because fall prevention has done about all that it can do. At this point, now we need to rely on fall arrest. So number 17, it says, unlike fall prevention, fall arrest assumes the inevitability of a fall because it couldn't be engineered out and is designed to stop the worker from hitting the level below the minimum, minimizing their injury. So we need fall arrest in addition to fall prevention to make sure that we're covered and have a way to protect us from a fall that is inevitable. So I've climbed many towers. I've never fallen off of a tower, but I have slipped on the ladder and my harness has caught me, and I've caught myself. You'll catch yourself slipping at one point, and that's when you'll be so glad that you had your harness on. But most of the time, you're in a pretty comfortable mode where you know your equipment well and you're using it accordingly. You won't have any problems. Number 18 is talking about positioning systems. So what we can see right there is a lanyard on this pole wrapped around it and connected to these D-rings on this person's hips right here. So we call those positioning. So if you need to, say, lean off the back of a ladder or lean out and away from something, you don't use your lanyards, which is what a lot of people will do, to tie around something. Lanyards are made for fall arrest, not for positioning. So the next question, number 19, says positioning systems do not need to be backed up with the secondary fall arrest system. And that's false, because we can see right here this person has a positioning system on, but they also have their fall arrest lanyard right here. So this is a little note that we need to pay attention to. So the maximum free fall for positioning systems is 2 feet. That means you only can, positioning lanyard like this is designed for you to only go slide about 2 feet. And it must, whatever you're tied to, like this pole, is he tied to this pole? What are you wrapped around a ladder? It needs to be able to handle a load of at least 3,000 pounds. So when we're talking about that, number 20 says maximum free fall for positioning system is 2 feet, and the anchorage point must support a load of at least 3,000 pounds. Reason why you need to know that, again, is if you're out in the field working and you do not have an engineered tie-off place, or you're wrapping a positioning belt around something like a ladder, will that ladder hold 3,000 pounds? Because when you fall with a force of 3,000 to 5,000 pounds, depending on how far you fall. And it will just tear whatever you're connected to out of the wall or out of the ceiling, and it won't save you. So the good way of looking at this stuff is, could this thing hold a car? If this thing could hold the weight of a car, then it can hold you if you fall. So that's, and a lot of these loads are 3,000 pounds sounds extreme, but it just depends on how you fall. So if you fall 20 feet versus 2 feet, when you're falling 20 feet, you're gaining momentum in your body weight, and all of that adds up to that 3,000 to 5,000 pounds of force that's going to be coming down on your body if you fall a great distance. And your fall arrest system needs to be connected to help prevent you from actually it needs to be able to be connected to things that can hold 3,000 and 5,000 pounds is what I'm trying to say. Let's move on from the positioning. Safety nets, we don't really work with safety nets. I never have. They're just a thing. So all we say is safety nets on number 21 must be installed so as the exposed worker can never fall more than 25 feet. So you'll find that information here. So that won't work for wind because we're higher than 25 feet. But that's one other way of doing this. Okay. So when we're talking about personal fall arrest, we need to talk about free fall. We started to, but we need to get into that a little more. Is there any questions so far? Okay. So free fall is simply this statement right here. Free fall is the distance traveled from the point where the worker starts falling to the point where the worker's fall arrest system begins to slow them down. So you can see you can be all the way up here, and that can be 15, 20 feet from the floor or higher. And as you fall, you're going to stretch. So you're not just going to fall 6 feet because your lanyard's 6 feet. You're going to fall farther than that. So you need to make sure that you're not going to hit the floor. One thing is important there. And what we need to do is wear our harnesses in a certain way that we limit our free fall. So in this little box right here, it says most legislation provides for a maximum free fall of 6 feet, since a free fall greater than this can potentially overload the system and injure the worker. So in question number 23, free fall legislation is limited to a maximum of 6 feet. Now this next section gets a little confusing, but it'll clear up here for you pretty quick. So we have the deceleration distance. That's important because when we fall, we have to decelerate. So the distance attributed to the shock absorber's activation, our deceleration distance is the distance attributed to the shock absorbers. So most lanyards should have a shock absorber that is on it, and that's going to cause additional resistance when you fall, and it's going to make it easier for you to slow down and not feel that full force of 5,000 pounds. But we're still going to stretch. So there's some safety factors that we need to put into play when we're looking at this stuff. So safety factor on question number 25 is the amount of distance between the worker's feet and the level below at the instant that the fall is arrested, prior to any bounce back up, because you could have a bounce back up as you're swinging around. So our safety factor distance should be set at a minimum of 2 feet. Okay. So what we're looking at is a total free fall distance. So a general rule for clearance, that's going to be question number 26. The general rule for clearance is you need 12.5 feet of clearance with the 6-foot lanyard. That means you need at least 12.5 feet or you're going to hit the ground when you fall. You may not hit that hard, but the reason being is you need 6 feet for free fall because your lanyard is 6 feet long. You need 3.5 feet for deceleration. That's going to be your lanyard shock absorber stretching, trying to slow you down without, just jerking on your lanyard really hard. This thing stretches you're going to have a little bit of slide in your harness when you fall at that force. So even if you got your harness tight, you're going to slide at least a foot. And then we want to have that 2 foot, that extra 2 foot of safety factor. So even though you could climb off a ladder and hang by your lanyard, you would only hang about 6 feet. But if you fell, you would have to add this extra 6 feet. So a total of 12.5 clearance is required. I've seen some different numbers where that's floated around. This is a fall protection plan that says you need 3.5 feet for deceleration. I've seen some that have upped it to like 6. That seems a little excessive. But, you know, in this fall protection plan, it's 12.5 feet clearance required.
Excuse me, I recall some years back, I believe one of the professors at the campus fell off of a turbine. You know, were they harnessed off?
Yeah, to know that, and that story always comes up when we get into harnesses. So that's Craig Porter, and he was climbing on a Met tower that was 80 feet, and he was wearing a harness, and nobody knows what happened is the problem. He just fell. And I will tell you, in my experience, he must not have been tied off or he wouldn't have fell, because they did an investigation, and he was just a younger guy that they were climbing a tower that I don't think they should have climbed, because none of them were really that trained. And there's where the problem came into play. So that was 10 years ago. And that's when I took the job over. Unfortunately, Craig had just started his job. I think he had been the program chair for about 2 months, and he had an accident.
Oh, wow.
Yeah. So Craig wasn't from the wind industry. I am. I've climbed, what I tell everybody, about 800 turbines. And I mentioned my father fell. We're not going to be climbing. I had that tower tore down as soon as I started the job, just because it's not representative of a wind tower anyway. Wind tower is much safer than what they were climbing on.
Okay.
So it was just an unfortunate accident where, in my opinion, I think he was watching other people and not watching himself, because he was the instructor and he just didn't pay attention to himself being tied off. That's what we're going to learn, because when you climb and move around, that's what we need to practice, is 3 points of contact and 100% tie off all the time.
Okay.
If we don't do that, then there'll be that instant, and it'll happen in the lab where you guys will get up there on our tower is only 10 feet. So, I mean, if you fell off it, it'd hurt your ankle, but it isn't going to kill you. But you're up there high enough to be hanging in your harness, to feel the weight of your body, and to know that you've got to stay tied off and climb around. And so what we're practicing is climbing techniques, and I'm going to be watching you when you're climbing on the tower. Are you doing 100% tie off? Because if you untie yourself and you're not tied off, that's how you fall.
Okay.
You just could slip.
Yeah.
So that's important. Good question. So we all have the potential of getting hurt, and we just need to be aware of moving slow. Don't get in a hurry. Make sure you understand your equipment and how it is supposed to be used. So number 27 says general for clearances. So what we say again, and in that homework, that should be that's C. 6 feet for free fall, 3.5 feet for deceleration, 1 foot for D-ring slide, and 12 feet for safety factor. And what I just tell everyone is make sure you're 15 feet off the ground. That's the easiest way to remember all of that stuff is wherever you're tied off, whatever you connect to, you're 15 feet off the ground. And then you won't hit anything. You should be able to just be in your lanyard like you're supposed to be. When I say hit, I'm talking about maybe actually hitting the floor with your feet, but you still will be decelerated no matter what. Swing fall is the next one. So number 28 talks about swing fall. Swing fall is simple to understand. It's the pendulum type swing that will happen to you if the anchorage is not located directly above the worker's head. So you don't want to tie off and then move diagonally away from your tie off point, because if you do fall, you're going to swing and you could swing into something that could cause an injury. So always try to make sure that your tie off point, as you see in the picture, this person is tied off, but they're starting to move a little bit to their left. And the more they move to the left, if they were to fall, technically this thing would swing them to the right. So that's all that is. Fall protection. Okay. So number 29 talks about the primary and secondary approach to fall protection. The primary form of fall protection refers to the first line of defense. So that's question number 29. Is simply our sense of balance and coordination, as well as any positioning system that assists the worker from falling. So we want to make sure that we're aware of our own surroundings and that we have our own balance and coordination. It seems pretty self-explanatory, but that's the primary approach. The secondary system of line of defense is the fall prevention or fall arrest system being employed. So that's going to be the guardrail caught you, or your harness actually caught you when you had a fall. So the number 30 would be the second form of fall protection is fall prevention or fall arrest systems being employed. Okay. I think the next section we get into is body supports, section 2. So that would start with question 31. So we're about halfway through this. Doing good. Body belts. So now we're going to start looking at the support systems and some of the harnesses and the differences between the harnesses and some of the weights, the numbers, like 5,000 pounds. So in section 2, number 31, it says body belts must be used for positioning or restraint, never fall arrest. So what we're talking about is this first little statement right here. Body belts must only be used for positioning or restraint, never fall arrest. The next question, number 32, is also important. All attachment points and load-bearing straps on your full body harness must have a minimum braking strength of 5,000 pounds. So that's the next statement. 5,000 pounds. That's important. Remember, whatever you're tying off to needs to be able to hold a car, 5,000 pounds. Because you're falling with the force of 5,000 pounds, your harness needs to be able to also have a minimum braking strength of 5,000 pounds. What we call the dorsal D-ring on the harness is what we use for fall arrest. That's the one that's going to be in the center of your back. Okay. And body belts, these types of body belts, we don't use really in the industry because body belts are not permitted for fall arrest in the United States. So question number 33 is just asking, could I use a body belt for fall arrest? Well, no, because that's what a body belt looks like. It's not going to keep you from slipping out of this thing if you fall. So 33 should be false. The next question in 34 is asking, where do you attach your lanyard to? Well, you're going to attach it to the back D-ring in the back of the harness. This is stuff that we'll look at when we each have a harness in our hands. Okay, so we're going to move forward to this section here. So I'm on page 16 of our book, and we're on question number 34 in our packet. So we say you attach your lanyard to the back D-ring. So this D-ring right here, that's what we will attach our lanyard to, and it needs to be a double-legged lanyard, not a single leg, so we can have 100% tie off. You've got webbing, adjustment points, leg straps. What we want to look at in the next page are some of the different types of harnesses. So there are several types of body harnesses where you need to name 5. So all you need to do is name these 5 harnesses right here. So a descent control harness. So it has a frontal attachment point that is used for manual or automatic descent. You guys generally have that on your harness as well. Confined space, this would be if you had to be lowered down or retrieved. You can see that you've got these extra D-rings right here on your shoulders, so you can be lowered or brought back up. That's another type of harness. A ladder climbing harness is one that simply has a D-ring right here in the center. It's very similar to the descent. A work positioning harness has D-rings on your hips to where you can connect that work positioning belt around something and connect to your hips. And then the last type of harness is the ones that we use, which are multi-purpose harnesses. They have a dorsal ring in the back. They have one right here in the front, so you can do ladder climbing like this one does. I don't see one here, it should. And they also have your work positioning D-rings on your hips for positioning belts. So all of the harnesses that we use are multi-purpose harnesses, and that's what you should be using. Any questions on the type of harnesses? Okay. We're into section 3. Now, before we go into section 3, this is a chart that gives you an idea of where you should be. So when I wear a harness, I usually wear a medium. I can wear a medium. Sometimes I'll wear a large. Just because you're a big guy doesn't mean you need an X large. All an X large harness is going to do is be too loose on you. So really you want your harness to be small, snug, and tight, because that's one of the things that you can do to make sure that you don't slip out of your harness. And that's something that we'll talk about when we get into discussing different ways of wearing your harnesses, different types of harnesses. While the minimum braking strength for most fall protection is 5,000 pounds, as we've already learned, the rated capacity for most harnesses is 310 pounds. This includes weight of the worker, including clothing and equipment. So even though it'll hold 5,000 pounds when you fall, you may have, if you weigh more than 310 pounds, then you may have to get a specially made custom harness to hold your weight. So there are some people that do weigh quite a bit. Whenever you're putting your harness on, as you'll notice, this guy just stands there with the harness. He kind of holds it and then untangle it and throw your shoulder straps on. Then do your leg straps, do your chest strap, and then tighten everything up. So once we get these on in the classroom, we'll work on learning how to tighten these things up right, because there's got to be a certain amount of tightness to it. You know, that's always something. Whenever I put a harness on and my lanyard on, I would always go over to and do a buddy check. Like whoever I was working with, just kind of let them look at my harness and make sure everything looks good in the back, make sure I'm connected properly on my dorsal ring. They'll usually just give you a tug so you know that you're all good to go. Okay. Let's move on down to section 3. Okay, first statement is important. Snap hooks and carabiners used in fall protection or rescue operations must be auto locking and withstand a 5,000 pound load. So snap hooks and carabiners, on question number 6, the key is auto locking. If you have a carabiner or a snap hook that doesn't automatically lock, it is illegal. You don't want to use that. You'll find some of this stuff out in the job site, workplaces, or you'll find an auto locking one that isn't auto locking because it's broken. You know, you need to retire those pieces of equipment. And just like your harness, you need to have your snap hooks and carabiners being able to handle 5,000 pounds. So the next question is asking hazards associated with a snap hook or a carabiner. When we're talking about snap hooks and carabiners, here we're talking about snap hooks. Those are snap hooks. Different connection. And let's see if we have a carabiner. Picture of a carabiner. This is a picture of a carabiner right here. But we'll come to that in a moment.
Is there a more efficient way to test the integrity of the snap hook or the carabiner besides just a regular pull test? You know, our body weight, you know, falling at already 5,000 pounds. Is there another way that we can make sure those are, you know?
Yeah, no, well, the pull test is just going to make sure that you're all hooked up properly.
All right, okay.
But when we're talking about these things, they're stamped. Yeah. There should be a stamp on them that tells you you're going to have to inspect them.
All right.
That's what you got to do. The reason being is because when you're working with this equipment, I mean, it could get damaged. You could like took your harness off, threw it in the back of your truck, and then a guy put a big heavy hydraulic press on your lanyard and he bends your hook. And nobody knows but you, because you're supposed to be inspecting that and make sure that nothing happens. Now, these things are pretty solid. You'll get a good feel for them once you get them in your hands. You'll look them over and you'll learn how to inspect them and you need to inspect them every time before you use them. So at the beginning of the day, in the morning, you grab your harness, you check all your carabiners, you check all your snap hooks, and make sure everything is working. The next problem that you have is going to be associated with the way that you connected it. Did you connect it properly, or did you make a mistake? So question number 37 says hazards associated with snap hooks and carabiners include forced rollout, which we'll talk about briefly, a false connection, which means that's where you don't realize you're connected, or you thought you were connected and you're not, or you're simply on a sharp edge where the sharp edge could cut through your strap or your lanyard. And those are things that you just need to be aware of. It's common sense, but also an important part of understanding when these snap hooks can be used and when they can't be used, how they can be used. So let's take a look at the snap hooks. So we see the snap hooks here. We know they need to be auto locking. We know that they need to have a minimum tensile strength of 5,000 pounds. And you always want to remember to have a smaller hook than the D-ring. Or just when you connect to these, what they're trying to show you is a proper connection method. Some of these methods are improper, like if you have a damaged hook and you can't get your lanyard, or if you have a hook that's the wrong size, it shouldn't be, but whatever you're trying to tie off to, you don't get a good bite, then you can end up with a forced rollout. This is false connection. This is where, Landon, I'm talking about, where you hook on to your lanyard on the back of your harness, but you didn't really do it.
All right. Yeah.
That's where you want to like say, hey, check my stuff for me. You know, you can reach back there and feel it, but it's just something to be aware of, that you want to make sure that all your hooks are right before you climb. It takes 30 seconds of your life to inspect these things really and look them over. It doesn't take very long at all once you get good at it. It's just like putting on your seatbelt in a car. It's what you just automatically do.
Safety first.
Yep. Okay. So a couple of things that we don't want to do. What we need to know. Question number 38, I think it bounces around a little bit here. I'm going to make sure I'm not getting lost. Question 38 says lanyards used for fall arrest must not be longer than 6 feet. So that's in the reading here. Let's look at these pictures here. We don't do that. We don't take and connect 2 lanyards to 1 dorsal ring. They're not made for that. We don't load any of our hooks over the gate. So this is the gate. So this carabiner needs to be turned so that all the weight is right here, not on the gate. We've learned that we can have false connections where we connect but don't really connect. That's why you always connect and tug and give it a look if you can. We don't generally tie 2 carabiners together. We don't tie 2 hooks together to lengthen a rope or lengthen our lanyard. We definitely don't take our lanyard and wrap it around something like a pipe and then clamp back on itself. That's where you need a special D-ring that goes over that first. That's made for you to tie. It'll go over it. We'll look at those in class. And this is obvious. They're just kind of hooking on to the side of a beam and then just asking for trouble there. There's no doubt about it. So question number 39 says, it is okay for your everyday lanyards to be connected together for extra length. We should know that should be false. Something that we just talked about. Okay. So all of that stuff are no-nos. Number 40 is asking a question. All lanyards that incorporate a, yes, a built-in shock absorber. When you look at these carabiners, we need to, again, these are self-locking. You have to twist this to unlock it. And then we want to have the weight up in the corner, not over the gate. There's a couple different types, some that look like a D, some that are a little more teardrop shaped. But the gate must withstand a load of 3,600 pounds. You're not supposed to use the gate, but even if you do happen to use the gate, that gate is still supposed to be rated for 3,600 pounds. The whole carabiner itself is rated for 5,000 pounds. So that's just one thing to note there. You would think that the gate would be 5,000 pounds too, but that's not how that's not the standard. So let's see here. Lanyards. That's where we need to get on the lanyards. So there's different types of lanyards that are out there. There are lanyards that have, this is a positioning lanyard. This looks like it has a shock absorber on it, but it's just a single connection point. Or I'm sorry, this is a shock absorbing lanyard. This one is. The one below it is the positioning. It's going to say normally positioning lanyards do not have a shock absorber, and they don't. So the positioning one is below that. That is a shock absorbing, but that is not a double-legged lanyard. We wouldn't want to use that. You can see here, this is the type that we generally use. They have a shock absorber as well. They stretch, and you've got two legs to it, and one snap hook that goes to your dorsal ring on your harness. So these two right here are going to connect to your ladder or connect to your engineered connection points when you're climbing around. And this one is also a double leg lanyard, 100% tie off like this one. It just has a shock absorber package instead of this bungee stretchy material. So they both work and they both can provide 100% tie off. Tie back lanyards are special type lanyards that you're going to be using that will allow you to tie around a D-ring. We'll have to look at some of those, but generally you're not going to be messing with those too much. So there's a bunch of stuff in this little teeny tiny thing where it talks about some of the information. I'm going to answer some of these next questions. So let's see here. Yeah. Lanyards with energy absorbers should not be used for fall without energy absorbers. So if we don't have those shock absorbers on there, we shouldn't use those because of the impact forces. So a lanyard should minimize the force on a worker to below 1,800 pounds with up to 6 feet free fall. Okay, so if that's just a lanyard, when we have a shock absorber on our lanyard, question number 41 says, a shock absorber will reduce the forces of the fall to below 900 pounds, but in doing so, that's going to cause you to extend that 3.5 extra feet. 42, you can never connect a snap hook to a carabiner. That's true. You don't connect snap hooks to carabiners. Number 43, non-locking snap hooks are often found on work sites and are allowed to be used. That's false. They might be found, but they can't be used. Number 44, you always want a larger snap hook than the D-ring. That's false. It's bringing us back up to some of these, because some of those questions are coming from this stuff right up here. So I'm trying to follow along. Number 45, you can attach 2 snap hooks or lanyards to one D-ring.
False.
Yep, false. Very good. Okay. Number 46, again, non-locking and manual type carabiners do not meet industry standards and should not be used. So I'm trying to drill that into your head. It's non-locking or manual locking. It's not auto locking. It has to be auto locking. Okay. I think we want to move down. Number 47 says, what is the purpose of an offset D carabiner? So what they're talking about is this. More recently, carabiners have been designed to take the majority of the load along the section across the gate rather than equally on both sides. Overall design, this type is called an offset D. That's where the shape of it is trying to force you to stay off of that gate. So it's to reduce the chance of the load going across the gate. That's question number 47. Number 48, we already talked about. Tensile strength for snap hook or carabiner must be 5,000 pounds with the gate face load of 3,600 pounds. So there's where we were just at. Okay, number 49 is going through these lanyards. Describe a shock absorbing lanyard. Again, it's just a lanyard used for fall protection that includes a shock absorber, some type of shock absorber. Number 50 is describe the shock absorbing stretch lanyards. That's these right here. So you might say something like stretch lanyards add flexibility and safety by shortening the length. I like them because they're not really 6 feet long. They shrink right up. And so when you tie them to your back, they shrink right up and they're not tangling in your legs. When we have a regular shock absorber that's 6 feet long, it can be a little bit long. So they have flexibility. They give you a little safety by shortening the length, but they still will protect you and extend when you fall. Describe a double-legged lanyard. 2 lanyards are connected at one end to provide 100% tie off. So this has 2. This has 2. If it doesn't have 2 hooks and a place to connect to your dorsal ring on your harness, then it's not 100% tie off or a double-legged lanyard. Number 52 talks about tie back lanyards. So tie back lanyard, we mentioned, is a specialty lanyard that can be used, but you have to know the different types of styles. There's one that has a movable D-ring, and the other one has a hook and a webbing to go around it, which is important, because when we go all the way up here, we see them telling us not to do that. You can do that with a tie back lanyard. It has to be made to do that. And most lanyards are not made for that. They're made to be attached to a separate lanyard or a separate D-ring, which is what they're alluding to. Okay. Any questions or comments? One thing we haven't talked about is an impact indicator. On your lanyard, there'll be an impact indicator that will tell you when a lanyard has already been used and the person has already fallen. Once they fall, they're stretching that lanyard out, and you don't want to use it again. So it's a one-time deal when you use that lanyard. It's not something that you're going to fall in. I fell in my lanyard last Saturday, and you know, I'm going to use it again today. No. Once you fall in it once, it's used. So you can tell if it's used because it'll have impact indicators. The stitching will be ripped out. So I want you, we'll look at the stitching on the impact indicators when we're in class on Wednesday. That's what an impact indicator is. Number 54 says a lanyard should minimize the force on the worker to below. That should be 1,800 pounds. That's without a shock absorber. Once we have a shock absorber on there, then we're limiting our fall from 5,000 pounds to only 900 pounds. Much, much different, and it doesn't stress your body as much. Number 55 says lanyards should have a energy absorber and limit the fall to a maximum of 6 feet. Yep. Should be connecting into that pretty soon. Let me see where I'm at here. This is talking about swing fall. Okay. Section 3, shock absorbers. Yep. That's the section that we're on. Move on down. Yep. Okay. We're not quite to section 4. Number, I think that's 56. Lanyard should be connected at or above the shoulder to minimize your fall distance. You don't want it to be connect. You don't want to be connecting down at your feet, because now you got another 6 feet that you can fall, or 5 feet, depending on how tall you are. (56) or 57. Most energy absorbers dissipate energy by extending, tearing fibers, and producing heat through friction to reduce the worker's impact. Okay. All right. Now we're moving into section 4. Is there any questions or comments so far? I'm going to take just a two-minute break here, and I'll be right back. And then we'll do this last section on anchorages. which is will be done in maybe 20 minutes or so. And that'll be all we are covering for the most part today. We want to look at some ropes and rigging, but that'll put us at about 2 hours of talking, which is long enough, I think, for most of us to sit here. So I will be right back if you give me just a pause. Okay, I'm sorry about that. I am back. Okay, so we have just a few more questions here. I think 17 questions on this last section. Anchorage is section 4. So again, you're starting to hear some of the same things over and over again. And that's okay, because we're just trying to get down some of the basics from this training packet, so we have a better idea of what we're supposed to do with our harnesses. So anchorages, when we talk about anchorages, we're talking about what it is that we're tying our lanyard snap hook to. So number one, pick an anchorage that will support 5,000 pounds. That's good. We've heard that many times. We know it needs to be able to hold the weight of a car, or 5,000 pounds can be a truck or a car. It's a lot of weight. So the way that I explain that is, if we were to take like a chain and hang a car from the beam that you're trying to tie off to, if you don't think that beam can hold that car, we're not talking about the car falling. We're talking about just let the car hang. That's 5,000 pounds, or roughly 5,000 pounds. So if you can look at something and go, I don't think that'll hold a car. If it won't hold a car, it won't hold you. And so that really eliminates a lot of things that you can tie off to. You start looking at it and you're going to tie off to that. But if you suddenly catch yourself thinking like you should be and going, that's not going to hold a car, well, there you just could have saved your life, and not tied off to something that you should not tie off to. So we need to pick anchorages that will support 5,000 pounds. We know we need to locate that anchorage directly above our work area. Okay. We don't want to connect to things like water pipes or electrical conduits, light fixtures, guardrails, even things that aren't designed to handle 5,000 pounds. Question number 3 under section 4 is getting into engineered standards. Engineered standards say a certified anchor, it's question number 3. A certified anchor is one that can support 2 times the actual load and have a safety factor of 2 to 1. All right, so let me explain. When we're climbing around in the tower, we'll see that there are places, they're usually painted yellow, not always, but there are places that are designed for you to tie off to. Those anchorage points are rated for 10,000 pounds because they are certified and engineered. So that means they can support 2 times the actual load and have a safety factor of 2 to 1. When we move to question number 4, a non-engineered or non-certified, or what we would call improvised, something that you chose to tie off to, thinking that this would hold me. And when you do that, again, it must be able to support 5,000 pounds for fall arrest, 3,000 pounds for work positioning, ascent and descent, and 1,000 pounds for restraint. So there's your numbers right there. So if it's non-certified, if you're doing work positioning, it only needs to hold 3,000 pounds. If you're raising and lowering something, 1,000 pounds. If you're going to use it for fall arrest in case you slip and fall, 5,000 pounds. So all those numbers are floating around out there, I know. So those would be non-certified, non-engineered, improvised anchorage points. Okay. So when we move to the next question on number 5, we start to talk about some examples of a secure anchorage point. Those are going to be structural steel members, precast concrete beams, possibly wooden trusses, strong wooden trusses. So most of the time, you can find something and use it as an anchorage point. Okay. Fall arrest system. So let's see right here. So number 6 is asking, an anchorage connector will be required. Give some examples. All they're talking about there is some types include cable or synthetic slings right here, roof anchors, and beam clamps. Okay. Moving on to number 7. We only got about 10 more questions here. Number 7, if 2 workers are required to attach to the same I-beam, it needs to be able to withstand, right there's your answer. 2 workers are required to attach to the same steel I-beam for fall arrest protection, then the I-beam should be capable of supporting a load of 10,000 pounds or 5,000 pounds each. So we're not necessarily talking about certified anchorage. We know non-certified anchors must be able to do 5,000 pounds, but if there's 2 people connecting to that, then that thing needs to be able to handle 10,000 pounds. And certified anchorages, engineered, already do handle 10,000 pounds. Work positioning, again, work positioning anchorages must be a system that limits the worker's fall to 2 feet or less. So when we're talking about the worker cannot fall more than 2 feet, in these cases, the anchorage must meet 3,000 pounds. For non-certified anchorages, or 2 times the foreseeable future. All right, again, positioning belts are 3,000 pounds, limits your fall to 2 feet. Different than your fall arrest, which is 5,000 pounds. It's trying to limit your fall to 6 feet. Number 9, the impact force varies based upon the worker's weight, the free fall distance, and the amount of energy dispatched by the system. So that's right here when we're talking about the impact force. So the impact force, when we fall, we're falling, we're up here, but we're falling, we weigh 200 pounds, but when we fall, that impact force up here is 5,000 pounds. We want it to be able to handle. So it just depends on the situation. So we can't always know exactly. So when we weigh these, we need to make sure that they can handle this. So we've already talked about the type of anchorage systems. There we can see certified anchorage systems, ones that are made by engineers. So the two classes are going to be a number 10, certified engineered, or improvised, non-certified. Okay, and we're gonna see our certified right there, two classes. Non-certified. Next question is, can a certified anchorage system be portable? The answer is yes, because it's certified. Could be a portable system. There's a bunch of no-nos in here. They're just running through most of the stuff that we've already talked about. So you should start to feel like you got a pretty good idea about fall protection. Talked about swing fall. We talked about the free fall distance. Talked about not connecting to anchorages like conduit, pipes, things that can't handle or hold 5,000 pounds. We've talked about you cannot connect two snap hooks or connect a snap hook to two D-rings. We know on number 12 that our certified anchorages are identified by paint or special markings. Number 13, one more time. Remember, a non-certified anchorage must be able to withstand a static load of 5,000 pounds for fall arrest, 3,000 pounds for work positioning. Well, it says 1,000 there. I think you got the answer given to you. It should be 1,000 pounds for fall restraint and 3,000 pounds for rescue. The next question is list 5 important considerations for anchorages. So all that is you to go through this list here and pick 5 of these. So we were already talking about those. Located directly above the worker. Do not connect to conduit, pipes, antennas, guardrails. Do not connect snap hooks, 2 snap hooks to 2 D-rings. Keep away from sharp edges. If you do, put a pad or carpet square to help protect any ropes where there might be sharp edges. Okay. Section 4, we only got 3 questions left here. And number 15 says a horizontal lifeline is a complete system comprised of, right there's your answer. A horizontal lifeline is a complex system comprised of a flexible line with connectors at both ends, securing a horizontal line between 2 anchorages or an anchorage connector. So what we're talking about is like, this is like a peg on a roof we don't really use these horizontal light, but if you're on a roof, you could connect these and stretch them horizontally, and you've got a cable that you can attach to. Let's see, there's another picture. I don't see another picture. But that's what a horizontal lifeline is. Flexible lines with connectors at both ends for securing horizontally between two anchorages. I don't have a horizontal lifeline anchorage kit, or we would play with it. But like I said, we don't really use it. Lastly, here we have OSHA 1926.502 D8 states the horizontal lifeline shall be designed, installed, and used under the supervision of a qualified person. So that person has to do the install, has to be certified to install those. And so we're not going to even do that really. We're not certified to do that as part of a complete personal fall arrest system. And the last one for this homework that you need to get done for Monday, number 17, is horizontal lifelines are classified as permanent or portable. So there's your last answer there. Then we stop because it just keeps going on and on and on and on and on. The next section is going to get into some stuff that we're going to be learning more about when we are on campus on Wednesday. So what are those things? So I'm not asking you any more questions because I feel like I've asked you plenty. And I feel like those are the most important parts. This is an SRL. We'll learn how to use one of these. We just hook them up above our heads, connect them to our body harness, and we'll practice using these in class. They're like a seat belt. They'll let you move until you move too quickly, then they lock. So if you start to fall, they immediately lock. Then the rest of the stuff is just talking about certain specialized equipment that we don't have. Like some of this fancy stuff for horizontal or self-retracting lifelines. We have some of this stuff. Let me see here. But I'm going to stop there for now, as long as you've got through that much, because once we get into our chapter reading and our homework, and then Wednesday we'll be done with this stuff. You guys will be working on your learning how to use your rescue equipment when we're on campus. So it just depends how far we go. When we talk about rescuing, we'll get into that a little bit later on another day next week. But there's quite a few methods that you can use to rescue someone with a rope grab, or a roll gliss. But I'm going to stop right there. So you got to about page 38, 40. No, let's see. Your homework stops on about page 33 of this book, just so you know. And the rest of it is over rescue training. So you don't need to go any farther than that as of right now. Okay. Okay. Is there any questions or comments over that big long section of stuff? I know a lot of information, but hopefully you're starting to put it all together.
I guess my question is like, if you can highlight, maybe some of the key things we would need for an exam regarding this section. Like what are some things we really should be honing in on, knowing for an exam?
The weight.
Okay.
So like number 13 is a big one.
Okay.
13 says, remember, non-certified anchorages must be able to withstand a static load of 5,000 pounds for fall arrest, 3,000 pounds for work positioning, 1,000 pounds for fall restraint, and 3,000 pounds for rescue. You know, you're going to have a couple questions on an exam over what is your anchorage supposed to hold? Well, we said 5,000 pounds about 5,000 times. So,
Right.
yeah. So you should have that one down. Certified anchors and non-certified anchors. We should know if it's an improvised, it can hold 5,000 pounds. With it being an engineered one, it needs to be able to handle 10,000 pounds.
10,000. Right.
Yeah, that one's a little tricky there. Know what your know what swing fall is, right? We talked about swing fall. Know that that's something that can happen. Know that you can't use body belts. Know that you can't use manual or non-locking carabiners. Make sure they're all auto locking. Know the proper ways to hook up your lanyard. So the term of like forced rollout, things like that, where we're looking at the pictures where you're making mistakes. It's pretty straightforward, but don't be like taken off guard by like a word like forced rollout. What's that? Well, you know,
Right.
that's what we were talking about when you don't hook up.
Be harnessed. Yeah.
Shock absorbers. Shock absorbers want to reduce your weight. This one we haven't talked about enough, but a shock absorber will reduce the forces of a fall to below 900 pounds. So that one's important. So a regular lanyard is going to do 1,800 without your shock absorber. You add an energy shock absorber, now we're down to 900. So what that means, yeah, we come from 5,000 all the way down to 900. So that's a lot less of a load on your body when you fall. When we get on campus on Wednesday, a lot of this stuff will start to stick a lot more because you're going to be having things in your hands too and seeing the different types of harnesses, putting them on and climbing around. The clearance, be aware of like the clearance when we talked about the general rule for clearance. So if you're tied off, you need 6 feet for free fall, 3.5 feet for deceleration, 1 foot for foot for your D-ring slide, and 2 feet for a safety factor. So, you know, you're going to see that number thrown at you because you need to be aware that when you fall, you stretch and you got to have extra length there. You know, all your lanyards should be 6 feet long. And know the difference between fall arrest and fall prevention. Remember, we talked about the differences there. So fall prevention is going to be guardrails. Fall arrest is going to be your harness, your lanyard. And for the most part, that's it, really. Okay. Try to get all that stuff straightened out in your head. I'm not going to ask everything out of this book. That's just the book that we use. And the questions in this little worksheet that I give you are really kind of the ones you want to focus on. Your tests are going to be multiple choice. So you're not going to have to write it out by memory or anything like that.
Oh, okay.
You just got to pick it. And, you know, sometimes when you write it out like this, it sticks in your brain a little bit better.
Wow.
You had to do just a bunch of multiple choice questions on this. But yeah, that's it. And I will go over, like, whenever we do a test, if you ask Landon, I will and I usually do it if I forget to do it. I'm going
Mhm.
to review for the test, and that's
Okay.
where I tell you where you need to focus.
All right. Yep.
And that'll help you a lot more. This is showing me that you've done the work, that you read that book with me, you looked through it, and I'm kind of forcing you to take your fall protection seriously.
Right.
Yeah, I mean, I gotta make you do a little work, and we can work on these worksheets. We sometimes work on them in class. So if you're like struggling to keep up, if you come to class, that's something you can kind of still do. If you're waiting for your turn to climb or something like that, you could have your laptop open and start typing in stuff if that helps. But we'll be pretty busy. Let's move on to knot tying. So this is just a couple, we're gonna watch a couple real quick videos and then we'll be done for the day. One of the things that we're getting into is going to be ropes and rigging. I'm going to try, I should have about a 3-foot piece of rope for you to keep and take home and practice. We're going to tie at least 3 to 5 different types of knots. And I'm going to have you demonstrate to me that you know how to tie these knots. It's important to be able to tie knots. I'm not one of the people that want you to learn 30 different ways of tying knots. I want you to know 5 really, really good ways to tie knots. So you always tie a knot correctly instead of trying to remember all the different kinds, because it just depends on how much you practice these. This first one is the clove hitch, and it can be done a couple different ways. But we use this to tie off round things that are like cable or something that's hard to hold on to, and you got to tie around it. So what you're going to want to do is practice this stuff maybe at home if you got a little piece of rope until it's like second nature to you. And then we'll learn how to do a method that's kind of like this. It's called this is still a clove hitch, but there's another one called a half hitch. But there's just another way of doing this, very simple. The videos help a little bit better than maybe a picture I have. So there you go. There's your clove hitch. It should have this little X look to it. I've got a couple pieces of paper in here that go step by step on how to tie a clove hitch. But if you don't like the paper, then you can watch the video. That might be a little better for you. And there's tons of videos on YouTube. This is the other one. So we're on Wednesday, we're going to be practicing these in the background, tying a bowling knot, which a lot of you might already know how to do some of these knots. If you already know how to do them, then we'll be able to go through that stuff pretty quick. And especially, I got a lot of guys who've been in the military. They usually know how to tie knots. But if it's been a while, that's okay. We'll go back through these and we'll learn, and you're gonna have to practice and tie some of these knots when you're up on the ladder. That's going to be the challenge. And this is a bowling knot. It's one of the best knots there is. It's pretty simple to do. The problem is you forget a step or two on how to do a knot, and then you've got a different kind of knot. You got a slip knot that is not going to hold the weight the same way that a bowling knot would. A bowling knot is so good. This knot is so good. They teach in Boy Scouts, you could wrap a rope around your waist and tie a bowling knot, and then you could get pulled up by that knot right there. So that's a good one for tying off anything that you want to hold the weight and lift up and down, and it's easy to untie. Okay, Well, it's 10:40, so we've been going for over 2 hours here. I think I wore you out, and today's lesson for your Energy 111 is going to be a real doozy. So you're going to want to try to make it to that class if you're in that class, and we'll be working through some heat loss, heat gain calculations. It is hard, but if you're not in that class, just work on your worksheets for this class and think about knot tying. If you've got some rope at home, maybe grab some and practice a little bit, but we'll go ahead and be practicing that on Wednesday of this week when we're on campus. If there are no questions, that's all I have for today, and I can let you guys go. Are there any questions for me? Okay, guys. Well, I'll let you go, and I will see some of you at 1 o'clock.
All right, have a good day.
Okay. All right. Bye-bye.
See you, John.
See you guys.